Hello, today I'm going to introduce you about my final project, 11675 course project, which is analysis of KDD 199. And my name is Ruwang. First of all, I will give you a task overview. What I'm going to do is to base our machine learning model and build up a network intrusion detector, which is a predictor model capable of distinguishing between bad and good connections, which is normal and attacks. The database I use contains hundreds of thousands of standard set of data to be audited, and it includes a wide variety of intrusions simulated in a military network environment. All the attributes can be divided into 41 attributes and one label. And the training set and testing set all have around 49,000 data set. The procedure I will go through have 4 steps. Step 1, I'm going to stratify the sampled 10% training and testing dataset. Stratified sample is randomly choose samples from stratified folds, and in this way it can help our model to be not overconfident to some patterns of dataset. And step 2, I'm going to build up 4 models based on the training data. The 4 models I'm going to use is naive Bayes, decision tree, bagging of decision tree, and also the random forest. And step 3, I'm going to run all these 4 models in local and evaluate all these models. Evaluate method is typically the cross-validation. I use 4-fold cross-validation in all the 4 procedures. And in the step 4, I'm going to compare models and run the best one on the Hadoop. The first model I'm going to use is naive Bayes. In naive Bayes, it has a very strong assumption, which that all the attributes are conditional independent on the label. This is a so strong assumption that it may cause many flaws. One flaw is it can be overconfident. So the result, whether to be many unlikely or even to be the probability is 100%. And here as a presentation, you can see the results of the naive Bayes. The correct accuracy is 92.9074%, and error is around 7%. Couple statistics, which is a very important value to evaluate the models of the statistics models, is 0.99, and mean absolute error is 0.0062. Root mean squared error is 0.0766. Relative absolute error is 12% around, and the root relative squared error is 48% around. And the test accuracy, as you can see, is 74.33%. Next, in order to improve the model, I try many other models. Decision tree is one of the models that apparently outperformed the naive Bayes. For the decision tree, I use J48 algorithm to train the tree. J45 use information gain to select the correct or the right attributes at the root, and then use this method to iteratively grow the tree and also in order to avoid the overfitting, it still use the post-prune technique to get the tree. As a presentation, at the PowerPoint, the figure you can see is the result of the trained decision tree. There are many attributes over there. Each node represents attributes. Here I have the results of four-fold cross-validation result. The correctly accuracy, which is 99.89%. Error is 0.16%. Kappa statistics is 0.99%, and the mean absolute error is 0.00002. Root mean squared error is 0.0116. Relative absolute error is around 0.4%, and the root relative squared error is 7.24%. And especially as you can see, the test accuracy is 92.31%. Compare the naive Bayes with decision tree. As you can see, the training process, the correct accuracy is 92%, increased to 99%. The kappa statistics from 0.8827 to 0.9992. This is a significant improvement. So the decision tree is much outperformed naive Bayes. From this hint, I will further use decision tree which is specifically J48, to do the further model. Bagging. Bagging is example method. It's a combination of various algorithms, and all the algorithm can be seen as a weak learner, and it uses the weak learner's vote method to decide which classification the data should be belong to. And in this project, I use all the algorithm as J48. And here is the result of my cross-validation. The accuracy in the four-fold cross-validation, the results of accuracy is 99.86% around, and the kappa statistics is 0.9977. Mean absolute error is also very small, and as you can see, the root mean square error, the relative absolute error, the root relative error, square error is as shown as in the PowerPoint. As you have to notice, the test accuracy is 95.21%. This is improvement from decision tree to bagging. The test accuracy improves. However, as you may notice, the training result may tie. So some of you may ask why the test accuracy can improve. Here is my explanation. J48 can be cause overfitting. The probability is much bigger than bagging because it uses vote method. The vote method can be very likely to avoid the overfitting. So as you can see, although the cross-validation may ties, but the test accuracy improves significantly. The last model I'm going to use is random forest. Why I'm going to use random forest from bagging is because random forest is also an example method. It also integrates many algorithms to the model, and then use a vote method to do the classification, regression, and other tasks, and operates all of this by constructing a multitude of decision tree at training time and output of the class. the algorithm is more you can say fancy than bagging. So here is my result of cross-validation. It can correctly accuracy. The correctly accuracy is 99%. Error is 0.07%. Capacitatics is 0.99, and the mean absolute error is 0.0002. The root mean squared error is 0.0075. The relative absolute error is 0.35%. Root relative squared error is 4.7%, and the test accuracy is 97% around. The result outperformed than the bagging, both from the cross-validation results and also from the test accuracy. So, random forest, which is example method, is the best method, and I'm going to run the random forest in the Hadoop. Notice that in this project, I use R in all the process to achieve the model, and then I'm going to use the R in Hadoop. First of all, I will give you the introduction of R, how to use R in Hadoop. R Hadoop is a set of packages for R language. It contains many packages. Firstly, it includes RMR, map-reduce interface. It includes mapper and reducer, which is described in R and then can call from R. And then I use the package still includes RHDFS. It can access HDFS by the simple R functions. And it can also copy data between R memory and the local file system. The third package, it has RHbase. It requires if you are going to access HBase. And the last but the not least package is PL by RMR. There are many common data manipulation operations. So in all of these packages, I run the random forest in R, and it can show a good result. So this is a presentation of my project, and thank you very much for listening.